Hi everyone! Today we'll be converting and optimizing an engineering CAD model using Meshmatic. First, let's have a look at the model in a CAD viewer. The model was designed in SolidWorks, and as you can see, it's a complex model of a robotic arm with many parts. I want to create a VR project using this model in Unreal Engine. But first, I need to convert the CAD model into Mesh and ensure that it is optimized for best performance in VR. This is where I can use Meshmatic to help me automate these tasks. Let's open Meshmatic. Click on the Add button to select the file you want to optimize. Meshmatic can read various file formats, including STEP, FBX, SolidWorks, CATIA, and SketchUp. After reading the file, a pop-up menu called the Import Assistant will appear. The Import Assistant helps you select the optimization profile that is most compatible with both your file type and your end goal. In the first step of the Import Assistant, you select the file type that best describes your model. You can select from 5 different model types, including the engineering option, which is ideal for assembly parts, or the manufacturing option for large industrial models. For this tutorial, I'm selecting the engineering type since our model is a robotic arm. In the next step, the Import Assistant asks you to select the target platform of your project. In this example, I want to make a virtual reality project, so I'm selecting VR. In the final step of the Import Assistant, you can see a list of suggested optimization profiles that best match your selections. In Meshmatic, optimization profiles apply different settings and optimization algorithms to prepare your file for the intended end project. In this example, I'm going to select the third VR profile, which is ideal for desktop visualizations. For advanced optimization options, you can click the Edit button to view the toolsets that automatically run for this profile. You can modify a profile or create a custom profile by adding or deleting individual tools and changing the LOD settings. The output settings let you make a bit more customization. If you want to generate UVs for your model, simply select this button and Meshmatic will automatically create a UV map. The Format section lets you select the file format you want your end file to be. I'm going to go ahead and select FBX since I want to import my file into Unreal Engine. And finally, you can select the location where you want your optimized files to be saved. The Import Assistant is now complete, and you can click on the Add button to add your file into the optimization queue. You can add more files to the optimization queue by clicking Add to begin the import process again, or simply drag and drop your file. In the optimization queue, you can always make last-minute changes to the settings for each file, such as the optimization profile, the export file format, or click on the edit icon to access advanced tools. Click on Optimize and Meshmatic will get to work. As Meshmatic is optimizing the files in the Queue tab, I can view the status of each file. The progress log at the bottom of the tab gives me a more detailed look into the optimization process, which will take a few minutes to complete. This may take longer depending on your file size and hardware. As you can see from the progress log, various algorithms are being applied to my file. Once optimization is complete, the files are moved to the Complete tab. The Show Results button gives you some insight on what your file looks like after optimization. As you can see here, the vertex and face count were dramatically decreased, which is great for our end project in Unreal Engine. I'm now going to open LOD1 and see how my output mesh looks. Using Windows FBX Previewer, I can see that my model has been perfectly tessellated and is ready for importing into Unreal Engine. For Unreal Engine users, there is an additional step of editing import options. We'll cover this in more detail in future tutorials. We'll also be discussing LODs and how they can be used in different projects. As you can see, the import process was seamless. Now that our file is converted and properly optimized, creating a 3D real-time visualization project in Unreal Engine is going to be much easier.